Class 11th Chemistry, Unit 3, Classification of Elements and Periodicity and Properties. In this video, we'll discuss how to determine position of elements in the periodic table and metals, non-metals and metalloids in periodic table. First of all, position of elements in the periodic table. Position means group number and period number. How can we find out group number and period number of an element? First, write electronic configuration. Then find out principal quantum number of outermost shell, and that is equal to number of period. The subshell in which last electron enters decide the block, that is S block, P block, D block or F block. Then group number can we find out after knowing the block. For S block elements, group number is equal to number of valence electrons. For P block elements, group number is equal to 10 plus number of valence electrons. For D block elements, group number is equal to number of electrons in n-1d and ns subcells. And for F block elements, group number is always 3. Now these are the some examples. If atomic number is 4, first write electronic configuration 1s2, 2s2. The principal quantum number of outermost shell is 2, that's why period is 2. Last electron enters this S subshell, that's why this belongs to S block element. And for S block element, group number is equal to number of valence electron, and these 2 is the number of valence electron, that's why group is 2. Z is equal to N, 1s2, 2s2, 2p5. This 2 is the principal quantum number of outermost shell. Okay, that's why period is 2. Last electron enters this P subshell, that's why block is P. And for P block element, group number is 10 plus number of valence electron. Okay, and how many valence electrons are there? Find out in this electrons present in 2s and 2p, that is 2 and 5, 7 electrons are there, and add 10, we will get 17. Group number is 17. Atomic number 11. 1s2, 2s2, 2p6, 3s1. That's why period is 3 from this. Block is S, this S. Okay, and group number is this 1. Valence electron is 1, that's why group number is 1. Z is equal to 14. 1s2, 2s2, 2p6, 3s2, 3p2. Period number is this. Outermost shell principal quantum number is 3, that's why period is 3. Block from this block is P, and for P block element, group number is, that is our number of valence electron is 2 plus 2, 4, add 10, that's why 10 plus 4 is equal to 14. Z is equal to 18, 1s2, 2s2, 2p6, 3s2, 3p6, period is 3 from this. Okay, block is P, last electron enters this P subshell, that's why block is P. And for group, this is 10 plus 8. How this 8? This is 2 plus 6, 8. That's why this is 18. Z is equal to 20. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That's why period is this, 4. Block is S, because last electron enters S subshell. And group is number of valence electron, that is 2. Group is 2. Z is equal to 25. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and after 4s2 electron enters 3d, and that is 3d5. Okay, now period is principal quantum number of the outermost shell. In this case, outermost shell is, this is 4th shell, that's why period is 4. And last electron enters this D subshell, that's why this is a D block element. And how can we find out the group number for D block element? Number of electrons present in n-1d and ns subshell. So this is 5 plus 2, that is 7. Z is equal to 29. Again, write the electronic configuration. This will come, that is 4s1, 3d10 for copper. Okay, and period is this. Principal quantum number of outermost shell is 4, that's why period is 4. And this is 3d10, last electron enters D subshell, that's why this is a D block element. And for D block element, group number is equal to, this is 10 plus 1, that is 11. There is even shortcut method to find out the group number for the elements having atomic number 21 to 29. Okay, this is only applicable for these elements. Group number is equal to sum of digits of atomic number. Okay, like this is atomic number 25. This is a D block element. Then group number is 2 plus 5, 7. This is a D block element. And the atomic number is 29. That's why 2 plus 9, 11. Is it clear? Now there is one question. The elements Z is equal to 117 and 120. In which family group would you place these elements and also give the electronic configuration in each case? Now dear student, it is very difficult to write the electronic configuration of the elements having such a large atomic number. Okay, I am giving one technique to write the electronic configuration of these elements. If you observe the atomic number in electronic configuration of group 18 elements, these are given. Okay, like this is atomic number is 2, and when you add this is 8, then this will become 10, next member. Then again you add 8, then this will come to the next member, 18, argon. Okay, and again if you add this is 18, then this will come 36, krypton. And again if you add 18, this will come 54. And in this 54, if you add 32, you will get 86. And in 86, if you add 32, you will get 118. And the outermost electronic configuration of these elements is NS2 NP6. Is it clear? Now, whatever the atomic number is given to you, try to correlate with these atomic numbers. In the same way, these are the group 1 elements. That's the same trend if you observe. This is 3. Okay, if you add 8, then this will come to 11. Again, if you add 8, this will come to 19. Then if you add 18, this will come to 37. Okay, and again if you add 18 in 37, this will come 55, and then add 32 in 55, we will get 87, and their outermost electronic configuration is NS1. Okay, now this is 117 is given to us, 117, and this 117 is very close to this 118. And for this 118, we know the outermost electronic configuration is 7s2 7p6. Okay, then for 117, what will be the outermost electronic configuration? This will be 7s2 7p5. Okay, this is the outermost electronic configuration, this one. And if you write the complete electronic configuration, you can write this is a radon, then this is 7s2. After 7s, electron enter 5f, 5f14, then 6d10, then 7p5. Otherwise, our work will be complete from this one. Okay, from this we can say period is 7, this. Then last electron enters p subshell, that's why block is p. And what is the group number? This is number of valence electron 2 plus 5, 7, and add 10. That's why 17. So this belongs to halogen family, group is 17. Okay. Now in the same way, atomic number is 120. Atomic number is 120. Now we can say that is after 118, electron enters next energy level, and after 7p6, next electron will go into the 8, and this will become 8s2. That's why electronic configuration of this is Jorgensen 8s2. From this we can find out that is this 8 is the principal quantum number of outermost shell. That's why period is 8. Last electron enters S subshell. That's why this is S block element. And number of valence electrons are 2. That's why group is 2. And this belongs to the alkaline earth metals. I think you are able to find out the group, period and block if atomic number is given to you. See, this is the one exercise question. In terms of period and group, where would you locate the element with Z is equal to 114? Okay. Again, we already discussed. If atomic number is 118, then its electronic configuration is 7s2 7p6. Okay, then if atomic number is 114, electronic configuration becomes 4 electrons less in outermost shell. That's why this is 7s2 7p2. And number of principal quantum number of outermost shell is 7. That's why period is 7. Last electron enters p subshell. That's why this is a p block element. And for p block element, 10 plus number of valence electron. That's why 10 plus, this is 2 plus 2, 4. Group is 14. Okay. Now write the atomic number of the element present in third period and 17th group. Now in this case, group and period number is given to us, and we have to find out the atomic number. Now what is given? Third period. Third period means quantum number of outermost shell is 3. Okay, and this belong to the 17th group. That's why this is a p block element. And if this is a p block element, we can find out the number of valence electron or number of electrons present in the outermost shell. That is 17 minus 10. This is equal to 7. Okay, then with the help of these three information, that is quantum number of outermost shell is 3, it is a p block element, it contains the 7 valence electron, we can write its outermost electronic configuration is 3s2 3p5. Okay, this is the outermost shell. Then we can write the complete electronic configuration of this element, and this will come 1s2 2s2 2p6 3s2 3p5. And that's why if you add these electrons, 2 plus 2 4, 4 plus 6 10, plus 2 12, plus 5 17. That's why atomic number of the element is 17. Again one exercise question. Assign the position of the element having outer electronic configuration. Position means again group number and period number. This is given first. ns2 np4 4 n is equal to 3. If n is equal to 3, then we can write this. This is 3s2 3p4. Now period is 3. Okay, block is p. This p. And when p block element, 10 plus 6. How this 6? This is 2 plus 4 6. That's why this is group is 16. Now this n minus 1 d2 ns2 and 4 n is equal to 4. If in this n is equal to 4, we can write this is the 3d2 4s2. Principal quantum number of outermost shell is 4. That's why period is 4. This d is a partially filled d orbital. That's why this is a d block element, and for d block element, group number is equal to number of electrons present in n minus 1 d and ns subshells. That's why 2 plus 2, that is 4. Okay. Now next one is n minus 2 f7 n minus 1 d1 ns2 4 n is equal to 6. If n is equal to 6, we can write its electronic configuration 4f7 5d1 6s2. Principal quantum number of outermost shell is 6. That's why period is 6. And this belong to the F block elements. How can we find out? Because this F is a partially filled subshell. Okay. And as we already discussed, all the F block elements belong to group 3. Okay. Now metals, non-metals and metalloids. The elements can be divided into metals and non-metals. Metals comprise more than 70% of all known elements and appear on the left side of the periodic table. Metals are usually solids at room temperature. Exception is mercury. Gallium and cesium also have very low melting points, 303 Kelvin and 302 Kelvin respectively. That's why these elements, that is gallium and cesium, melt when kept on our palm, because our body temperature is greater than these temperatures. Metals usually have high melting and boiling points. They are good conductors of heat and electricity. They are malleable. Malleable means can be flattened or can be beaten into thin sheets by hammering. And ductile. Ductile means can be drawn into wires. Non-metals are located at the top right hand side of the periodic table. Non-metals are usually solids or gases at room temperature with low melting and boiling points. Boron and carbon are exceptions. They are poor conductors of heat and electricity. But one form of carbon, that is graphite, it is a good conductor of electricity. Most non-metallic solids are brittle and are neither malleable nor ductile. The elements become more metallic as we go down a group. The non-metallic character increases as one goes from left to right across the periodic table. In the modern periodic table, a zigzag line separates metals from non-metals. You can see this is a part of a periodic table. This is a zigzag line. You can draw this. Okay, this separates metals from non-metals. And the elements which are lying on this border line, that is silicon, germanium, arsenic, antimony, and tellurium, these are the bordering this line and show properties that are characteristics of both metals and non-metals. That's why these are called semi-metals or metalloids. Now there is the one question of your exercise, that is your index question. Considering the atomic number and position in periodic table, arrange the following elements in increasing order of metallic character. Increasing order of metallic character. As we already discussed, if we go from left to right, metallic characters decreases, and if we go from top to bottom, metallic characters increases. Okay. Now, if you place these elements in the periodic table, okay, in this case sodium, this is alkali metal Na, okay, and this is beryllium. This position of beryllium is at this place in the second group and second period. Then this is magnesium. This belongs to second group and third period. Okay. Then this is after that silicon. This is a group 14 element in third period. Silicon. Phosphorus. This is a group 15 element in third period. This is the position. Okay. Now we can say which one is the most left hand side. This is the most metallic. That's why least metallic is, you can say this is phosphorus. Then silicon. Okay. This is phosphorus and this is silicon. Then out of these two, which is less metallic? As we discussed, down the group metallic characters increases. That's why magnesium is more metallic than beryllium. That's why beryllium, then magnesium, and then sodium. This is the increasing order of metallic characters. Okay student, subscribe my channel to new videos from this chapter. Thank you.